Hello and welcome to a GCSE maths walkthrough, and we're going to be looking at the 2023 practice paper 2, which is a calculator paper, and that is on the higher tier. So if you are doing the foundation, please have a look at my other video. I have done exactly the same on the foundation tier. And I will also be doing paper 3, which will be the second calculator paper for both higher and foundation. So please have a look at those when they come out as well. So just before we start, I'm just going to go through a few things. First of all, it will be really good if you follow along at home. That's probably the best way to revise. So I will put this paper in the video description, a link to it. It's taken from a website called Maths Genie. So you can print it out if you want, or just do it on your phone or your computer. I don't mind, but it's definitely best to have a go at doing it before I go through the answers. So try and have all of the correct equipment with you, including your calculator. And then just a few extra things. Remember, whenever you're given any diagrams, they're not accurately drawn unless they're specifically told otherwise. Okay, so if you've got any angles and things like that, it's not going to be accurate unless it says so. And finally, probably the most important thing whenever you're doing a maths paper is to show your workings out. Your teachers will always tell you to do this, and rightly so, because you gain marks for your workings out even if you've got the answer incorrect. So, I think I've gabbled on for long enough, so let's get cracking. Question 1. The table shows the probabilities that a biased dice will land on a 2, 3, 4 or 5, which we can see here in the table. The probability the dice lands on a 6 is 3 times the probability the dice lands on a 1. Fred rolls the biased dice 200 times. Work out an estimate for the total number of times the dice will land on a 6. So first of all, we need to calculate these missing probabilities. Now, the key with probabilities is that they always sum to 1. If they're mutually exclusive, all of the probabilities will sum to 1. So what we can do is add these probabilities together and then take them away from 1, and that will give us the total of these two. So we're going to do 1 subtract, so the sum of all of these, so that's going to be 0.1 plus 0.17 plus 0.12 plus 0.09. I'm just going to type all of that into my calculator over here. And you can see when you type it into the calculator, it gives you a fraction as the answer. But if you just press the SD button, it converts it to a decimal. So I think for this, I'm going to use a decimal. So 0.52. That means that these two probabilities sum to 0.52. And now if we look at this line here, we know that this probability is 3 times this probability. So if we just call this x for argument's sake, then this one, the probability of rolling a 6, well, that's going to be 3x because it's 3 times this one. And we know they sum to 0.52, so we can just write down an expression or an equation for this. So x plus 3x equals 0.52. If we just simplify this, that means that 4x is equal to 0.52. And divide both sides by 4, we get x is equal to 0.13. So the probability of it landing on a 1, well, that is 0.13. Let's just write that down. And the probability of it landing on a 6, well, that's going to be 3 times 0.13, which is 0.39. So let me just rub that out and put 0.39. So now we've got all of the probabilities, we can answer the question. So Fred rolls the dice 200 times. Work out an estimate for the total number of times the dice will land on a 6. Well, the probability of it landing on a 6 is 0.39. If he rolls it 200 times, well, we need to do 200 multiplied by 0.39. So let's just type that into the calculator. 200 times 0.39, and that gives us 78. So that is our answer, 78 times. And it is only an estimate. We're not saying that it's going to land on 78 times. That's just the best estimate that we can use. Question 2. Complete the table of values for y equals 2x plus 6 minus x squared. Now, with your calculator, there's a really cool tool that you can use, which will give you a table of values. So you may already know, but it might be completely new to you. And I'm not saying use it. but I definitely would recommend using it. It will save a bit of time. So what you do is, at the moment on your calculator, you should be in calculate mode, which is just mode 1. To change the mode, if you click on this menu button up here, you can see we're in calculate mode. What we need is table mode, which is number 3. So you can press 3, or you can just go along until you get to 3, and you can see it says table. If you press equals, now we need to type in the equation. Now you've already got f of x equals, so you don't need this first part here. That's just the same as y. All you need is this part here that I'm highlighting. So 2x plus 6 minus x squared. So to type that in, so first of all we've got 2x, so it's 2, and then x is this red x here. So you may have never used this before, but because it's in red, you have to type in alpha first and then close brackets. So alpha, close brackets, we've got the 2x, and then plus 6, and then minus x squared. So minus x again, alpha, close brackets, and then the squared, which is over here. So we've got our equation. So once we've got our equation, we just press equals. You don't need to worry about this. This is just if we've got 2 equations, but because we've only got 1, we can just press equals. And now that takes us to this page. We just need to enter the start and end values. So we're starting at -2. So we just type in -2, press equals. The end is 4 equals. And then the step, that refers to what are we going up by each time. And we're going up by 1 each time, so we can leave that on 1. Press equals, and hey presto, we've got our table of values. Just be really careful because this table of values goes across, whereas this one goes down. So you just need to switch everything around. So you can see that when x equals -2, y equals -2. So that is our first one. So let me just get my pen tool out and write that in. So when x equals -2, y equals -2. When x equals -1, y equals 3, which we've already got, so we know we've done it correctly. When x equals 0, y equals 6. When x equals 1, y equals 7. If we just scroll down. When x equals 2, y equals 6, which we've got. When x equals 3, y equals 3. And finally, when x equals 4, y equals -2. So you can see that although it might take a bit of time typing in the equation, once you've got that, you know, it just spits out all of the data for you. So there's not much after that. So it might save a bit of time. And obviously, as long as you type the equation in correct, you shouldn't make any errors. Okay, part B. On the grid, draw the graph of y equals 2x plus 6 minus x squared. Exactly the same equation we've got here. For values of x from -2 to 4. So all we're doing is we're plotting this data from the table onto our graph. So when x equals 2, when x equals -2, y equals -2, that's going to be here. Then we've got -1, 3, which is here. 0, 6, which is here. 1, 7, which is here. 2, 6, which is here. 3, 3, which is there. And finally, 4, -2, which is here. So we've got a nice looking parabola. And now, obviously, we're not going to be using a ruler for this. We're going to be going freehand. So as accurately as you can. Obviously, it's not going to be perfect, but try and get it as neat as you can. Obviously, this point is the apex of our graph. I'm just going to go down. So I'm just feathering it. And obviously, you have to use a pencil, because if you go wrong, you can't rub it out if you're using a pen. So that looks pretty good to me. I'm quite happy with that. Okay, let's move on to part C. Use your graph to find estimates of the solutions of the equation 2x plus 6 minus x squared equals 0. So basically, it's the same expression as we got here, but instead of y equals, it's 0 equals. So what we do is we draw the line y equals 0. Let me get my line tool out. I'm going to draw the line y equals 0. I'm going to make that a bit thinner because that's a bit thick. Let's make it red just so it stands out. So that's the line y equals 0. And all we're doing is looking at where does our graph cut this line. And there are 2 points. So let me just highlight those in green. So we've got this point here and we've got this point here. So what are the x values? Well, it's between -1 and -2. It's definitely closer to -2. So I'm going to say x equals negative 1.7. That's one solution. And my other solution is going to be when x equals this point here, which I'd say is roughly 3.7. Okay, these figures, there is a margin for error with your answers. So as long as you're within sort of 0.2, then you should get the full marks. Question 3, use your calculator to work out this calculation here. Write down all of the figures on your calculator display. Now, first of all, we need to change the mode. Remember from the last question we were in table mode, so we need to get out of table mode. And to do that, if we just press the menu button again, you can see we're in table mode. You can either press 1 or just go back till you get to calculate, which is mode 1, and then press equals, and now we're back to calculate mode. So we need to enter in this expression here. So the first thing I'm going to enter into the calculator is the square root symbol, because all of this is under the square root. So we do the square root, and then we've got a fraction. So we type in the fraction button. Automatically takes me to the numerator. So I'm going to type in the expression in the numerator, which is tan of 20. Notice it automatically opens up a bracket. So you have to close that bracket after you've typed in the value. And then plus sine of 25. So sine 25, close brackets. Go down to the denominator. And then we've got tan of 25, close brackets, minus sine of 20, close brackets, and that's everything. So we just press equals, and we do need to write down everything on our display. So we've got 2.515106913. So that is worth 2 marks. I'm not sure how the marks are split up, but as long as you give this value here, you will get the 2 marks. Okay, let's move on to part B. Write your answer to part A correct to 2 decimal places. So nice rounding question here. So 2 decimal places. So this is our first decimal place. This is our second decimal place. So if I just put a line here, you can see because this value is a 5, we're going to round up. So we're going to round 2.51 up to 2.52. And that one is just worth 1 mark. Question 4. Work out this calculation here and give your answer in standard form. So we're going to use our calculator for this for sure. So if I just clear this, so if we write in everything we've got here, so we've got open brackets 2.16 multiplied by 10 to the power of negative 5. So the power button here is this one. And now let's just type in negative 5, press right to get out of that, and then we need to close the brackets. Divided by, open brackets, 2.5 multiplied by 10, and this time the power is negative 4. So to the power of negative 4, come out of that and close brackets. So that's everything. Press equals, and again it gives it to us as a fraction, so just press SD, and we've got our answer. That's obviously not in standard form, but let's write it down first. 0.0864. Now we need to write this in standard form. So just as a reminder, whenever we write something in standard form, it's going to be something multiplied by 10 to the power of something. Okay, now this value, what we put in here, this has to be between 1 and 10. Okay, but it can't equal 10. So if I just give that a letter A has to be greater than or equal to 1. Okay, it can equal 1, but it definitely has to be greater than or equal to 1, but it has to be less than 10. So with this number here, what value can we use that uses these numbers? Well, it's going to be 8.64. So 8.64, that we would call that our base number. So it's going to be 8.64 multiplied by 10, and then what is our power? Well, if 8.64 is here, if we're multiplying by 10, we're going to go this way, but we have to go to the left. So it's not going to be a positive power, it's going to be a negative power. And we're going 2 places to the left, so it's going to be negative 2. So this is my answer. Question 5. The density of orange cordial is 1.21 grams per centimetre cubed. The density of carbonated water is 1.01 grams per centimetre cubed. A drink, that should say a drink, I think, not an drink, that doesn't make sense. So a drink with a volume of 280 centimetres cubed is made by mixing 1 part of orange cordial with 7 parts of carbonated water. Work out the density of the drink. So let's just remind ourselves what density means. How do we calculate density? Well, density, let's just write down the formula here. Density, that is equal to the mass of something divided by the volume of something. Okay, so that's how we calculate mass. We need to calculate, that's how we calculate density. We need to calculate the density of the drink, and you can see we've got the volume of the drink, we just don't have the mass of the drink. So this is what we're going to need to calculate, the mass of the drink. Now, first of all, let's take a look at this line here, because we've got some information that we can use. A drink with a volume of 280 centimeters cubed is made by mixing 1 part of orange cordial with 7 parts of carbonated water. So we can work out the volume of each individual part of that drink using this information. So you can see that there's 8 parts in total, 1 plus 7. So to work out what each part is worth, we can just do 280 divided by 8. And let's just pop that into the calculator. 280 divided by 8, and we get 35. So 35, and so that's 35 centimeters cubed. So that is what 1 part is worth. So what is the volume of orange? Well, there's only 1 part of orange, so we can say that orange is equal to 35 centimeters cubed. And carbonated water, I'm just going to put water for short. Well, that's 7 lots of 35. 7 times 35. Just times that by 7. And we get 245. 245 centimeters cubed. So now we've just done all of this, let's have a look at what we need to calculate. So we need the mass of the drink. And to do that, we need the mass of each individual part. So we need the mass of the orange and the mass of the water. And we can do that using these 2 points. So first of all, if we focus on this one, we've got the density of orange, and now we've got the volume of orange. So with those 2 bits of information, we can work out the mass. So if we just rearrange this formula, so mass is going to equal the density, I'm just going to put D for short, multiplied by the volume. So let's write this down here. So mass of orange, it's going to be the density of orange, which is 1.21, multiplied by the volume of orange, which we found out is 35 centimeters cubed. We can type that in, 1.21 multiplied by 35, and we get 42.35. 42.35, and that will be in, that's the mass, which is in grams. And now let's do exactly the same with the water. So we look at this point up here. So mass of water, well, it's going to be the density of water, which is 1.01, multiplied by the volume of water, which we found to be 245 centimeters cubed. So 1.01 multiplied by 245, and that gives us 247.45 grams. So now we've got the mass of the orange and the water, we can work out the total mass just by adding these together. So I've already got this one saved in my calculator, so I'm just going to add on 42.35, and that gives me 289.8, I'm just going to put 80 grams, and that is the total mass. So now we've got that, we can work out the density. So the density is going to be the total mass, which we've just worked out, 289.8, divided by the total volume, which was given to us in the question, which is 280. So we're just going to divide that by 280, and let's have a look. We get 1.035, and that will be in grams per centimetre cubed. So this here is my final answer. So let's write that in, 1.035. Now you can do a dummy check of your answer. I'm not saying that it's going to be 100% correct, but the density should be between the 2 densities that you've been given. So it should be between 1.21 and 1.01, and the reason for that is because it's a mixture of both products. So it should always be between those two densities, which it is. Question 6. ABC is a right angle triangle. The point D lies on the line AC, which we can see here. And we've been given some dimensions, so let's first of all write those in. So AB is 9 centimeters. BD is 13 centimeters. Sorry, BD is 13 centimeters. And CD is 4 centimeters. And let's just get my highlighter out again. Work out the perimeter of triangle ABC. Give your answer correct to 3 significant figures. So ABC is the big triangle. We need to work out the perimeter of that. So first of all, well, we've been given AB already. And we'll need to calculate AC. We've got DC, so we just need to calculate, first of all, this missing line here. So let me just highlight that in red. So we need to calculate this line here. And because we've been given BD, we can, using Pythagoras. So we've been given 2 of the side lengths. We can calculate the shorter side length using Pythagoras. So we're going to do 13 squared minus 9 squared, because we've got the hypotenuse. So let's just type that into the calculator. 13 squared minus 9 squared. And that will give us 88. And obviously this is not 88. We need to square root our answer. So the square root of 88. So square root answer equals 2 root 22. So root 88 is the same as 2 root 22. I'm not going to round that. I could write it as a decimal, all of this. But I'm just going to leave it as a surd, just because it's a lot neater. So this is 2 root 22. So now we do have AC, because it's basically these two added together. Now we just need to calculate the hypotenuse. So we need to calculate this length down here. And we can do that using exactly the same method, because this is also a right angle triangle. But this time this is the hypotenuse. So we're going to add these two. So we're going to square these two side lengths and add them together. So we've got 9 squared plus this squared. So it's these two side lengths added together. So I'm going to put them in brackets. 2 root 22 plus 4, and then all of that squared. So let's type that into the calculator. We've got 9 squared plus, in brackets, 2 root 22, and then we need to press the right arrow to come out of the surd, plus 4, and then close brackets. So all of that squared. And I am going to write this down now, like the whole thing. So we get... Oh. So sorry about that, my phone just went off, but let's get back to where we were. So we squared both of the shorter sides of our right angle triangle and added them together to give us this. But then we need to square root this answer to give us our hypotenuse. So if I just type in, where's the square root button? Here it is. Square root answer, and that gives me this value here, which is the hypotenuse. So we just square rooted this, and that gives us 16.12596,205, and that is in centimeters. And that's always good when you get a value that's greater than our shorter sides. And now we've got the hypotenuse, we've got all of the dimensions of our triangle, so we can calculate the perimeter. So this value here that we've just calculated, this is the hypotenuse that goes here. So let's just add everything together now. So we've got 9 plus 2 root 22 plus 4, that's the base of our triangle, and then plus this value here, so 16.12596,205, and I'm going to type this into the calculator, and you can see we get a value of 38.50679,357 centimeters. So that is our perimeter, but this isn't going to be our answer because we need to round it to 3 significant figures. So 3 significant figures. So that's the first, second, third. So let's just put a dash line here, and you can see we're clearly going to round this down to 38.5. So our answer is 38.5 centimeters. Question 7. A number, m, is rounded to 1 decimal place. I always get confused when it says a number and then it gives us a letter, but oh well. So the result is 9.4. Complete the error interval for m. So we've got a number, and when we round that number to 1 decimal place, the result is 9.4. Now, if we're rounding something to 1 decimal place, it has to have 2 decimal places in it. Otherwise, we wouldn't be able to round it. So what we do is we subtract 0.05 to get our lower bound. So our lower bound will be 9.35. And we do exactly the same thing, but in the other direction to get our upper bound. So we add on 0.05. So that will be 9.45. So our lower bound is 9.35 and our upper bound is 9.45. And you could just check that. So if we were to round this to 1 decimal place, that would round up to 9.4 because this 5 tells us to round up. But if it was any less than 9.35, so if it was 9.34, then that would be rounded down to 9.3. So this is the minimum value we can get. On the upper bound, it's slightly different because it's not saying it's equal to 9.45. It has to be less than 9.45. Because obviously, if you do round this to 1 decimal place, it will be rounded up to 9.5. So it is still the upper bound, but it has to be less than 9.45, which you can see here because there's no equal sign for the inequality. Question 8. ABC is a right angle triangle. Calculate the length of AB. Give your answer to 2 decimal places. So AB is this line here. We need to calculate the length of this. Now, whenever you're given a right angle triangle and you've been given an angle and a side length, always think of SOHCAHTOA. Okay, so you'll be using SOHCAHTOA for this. So I always like to write it down. So SOHCAHTOA, and there's a reason I like to write it like this. So let's first of all think about what information we've got. So we've got this angle here, and this is the length we're trying to work out. So what is this length? What is the name of this side from the perspective of this angle? Well, it's the opposite side length. So we need to work out the opposite side length, and the side length that we already have is this one, which is the hypotenuse. So the hypotenuse. So from these 3 trig functions, which one involves the hypotenuse and the opposite? Well, it's the sine function. It's this one here. You can see we've got the O and the H involved with it. None of these have O and H in. So it's this one here. So this function, so let's just write out what it means. So this is the sine of an angle. So sine of an angle is equal to the opposite over the hypotenuse. So because we want to work out the hypotenuse, we just have to rearrange this equation. So if we rearrange this equation, well, that's just the opposite is equal to the sine of our angle times the hypotenuse. So let's just put in everything we've got. So it's going to equal the sine of our angle, so that's the sine of 38 degrees, multiplied by the hypotenuse, which is 16. So let's type that into the calculator. Sine of 38, remember to close the brackets, multiplied by 16, and we get this value here. So let's first of all write down the whole thing. 9.850583, running out of room, 605. I've just about squeezed that in there. Okay, so we need to give that to 2 decimal places. So let's just put our line in. So that's the first decimal place, that's the second. So it's going to be here, and yes, we can clearly see that we're going to round down. So that's going to be 9.85. And it's definitely less than the hypotenuse, so you should be at least fairly confident that you've got the right answer. Obviously, if you had an answer greater than 17, then you know you've definitely gone wrong. But I think this probably is the right answer. Question 9. Holly recorded the heights in centimetres of some girls, and she used her results down here to work out the information down here in the table. And then Holly drew this box plot for the information in the table, and the box plot is not fully correct. So there's something wrong with the box plot. Write down 2 things Holly should do to make the box plot fully correct. Okay, so we're not just looking at what's wrong, we'll have to write down what she should do to make it correct. So let's go through each of these rows. So the least height is 144. That's this point here. So that looks right because that's 140. So 142, 43, sorry, 41, 42, 43, 44. So that's definitely right. Interquartile range, 19 centimetres. Well, the interquartile range is the difference between the upper quartile and the lower quartile. So what are these 2 values? Well, this value here, that looks like it's 174. And this value, well, that looks like it's 154. Okay, So the interquartile range she's put down on the box plot as 20, where it should be 19, so that's wrong. So the first thing we can say is that, well, one of these needs to be wrong. We don't know which one yet, so let's go through the rest of the table first. The median, 161, that looks like that's correct, so that's fine. The upper quartile, 174, well, that's right. And finally, the range is 42. Well, the range is the difference between the highest value and the lowest value. So the highest value, that is 185. And the lowest value, well, that is 144. Which is, the difference between these two values is 41, not 42. So that is wrong. So what does she need to do to make the box plot correct? Well, the interquartile range is wrong. So either the upper quartile is wrong or the lower quartile is wrong. But we can see here that the upper quartile is correct. So it must be the lower quartile that needs changing. So the lower quartile needs to, what does it need to do? So do we need to move it down or up? Well, at the moment, the interquartile range is 20. So we need it to get smaller. So the lower quartile needs to be shifted upwards. So lower quartile needs to move right one line to, we could say, to 155 centimeters. So now if we look at the second thing that we need to change, well, it's definitely to do with the range. So either the greatest height's going to be wrong or the least height's going to be wrong, but we can already see from the table that the least height is correct. So this one is wrong. So the greatest height needs to move. Is it going to move left or right? Well, at the moment, the range is 41. It needs to be 42, so it also needs to move to the right. It needs to move to the right, and that's by one space, or one line, to 186 centimetres. And those are our two things. So just be careful. You're not just saying what's wrong with it. You have to say, for this question, you have to say what she should do to make it correct. Question 10. A group of people did a test. The number of children who took the test to the number of adults who took the test, so the ratio between these two is 3 to 5. The ratio of the number of children who passed the test to the number of children who failed the test is 4 to 1. And the ratio of the number of adults who passed the test to the ratio of the number of adults who failed the test is 7 to 2. What fraction of the people passed the test? Now, there does seem to be a lot going on here, but basically there's two things that we're looking at. We're looking at the person who took the test, whether they were a child or an adult, and whether they passed the test or not. So they either passed or failed. So what we can do is, if we set up a probability tree, you don't have to do this. This is just one option, but this is what I'm going to do. So the first branch I'm going to look at is who took the test. So whether they were a child or an adult. So we can look at the first line. So this one here to tell us that. So the ratio of the number of children who took the test to the number of adults who took the test is 3 to 5. So you can see that there are 8 parts in total. So the number of children, or the fraction of children, would be 3/8, and the fraction of adults would be 5/8. We can write that down here. So 3/8 and 5/8. And now we can look at whether they passed or failed the test. So let's do another set of branches. So for both the children and the adults. So here I'm just going to put P for passed and F for failed. So pass and failed for each type of person. So let's look at the children first. So the ratio of pass to fail is 4 to 1. So there are 5 parts. So 4/5 passed and 1/5 failed. So passed would be 4/5, failed would be 1/5. So that's that one. And now if we do the same for the adults, the ratio is 7 to 2. So there are 9 parts in total. So 7/9 passed the test and 2/9 failed the test. So now let's look at the question. What fraction of the people passed the test? So that's going to be the children who passed the test and the adults who passed the test. So to work out the children who passed the test, we multiply. Remember, we always multiply up the branches. So it's going to be 3/8 multiplied by 4/5. And I think I can just do that in my head. That's going to be 12/4. 40. Okay, I'll leave that for now. I could simplify that, but I'll just leave it like that. And now we need to look at the adults. So it's going to be, we're going to go up this, let's just highlight it. We're going to go up this branch here. So that's the adults who passed the test. The first one I'll just show you was the children who passed the test. So we went up that branch there. So for this one, it's going to be 5/8 multiplied by 7/9. And I can do that as well. So that's going to be 35 over 72. And now we just need to add these fractions together. So we're going to do 12 over 40 plus 35 over 72 because we're looking at the total. And I will use a calculator for this one. So 12 over 40 plus 35 over 72. And we get 283. Let's put it down here. 283 over 360. And that is my final answer. Question 11. Yesterday it took 7 cleaners 3 hours and 20 minutes to clean all the rooms in a hotel. There are only 4 cleaners to clean all the rooms in the hotel today. Each cleaner is paid £11.50 for each hour or part of an hour they work. How much will each cleaner be paid today? Right, okay, so for the first line it says 7 cleaners. So 7 cleaners. How long does that take? 3 hours and 20 minutes. Now I'm just going to convert this just to hours because 20 minutes is a third of an hour. So that would just be 3 1/3 hours. So I'm just going to write that instead. So 3 1/3 hours. And we want to work out how long it, first of all, we need to work out how long it takes for 4 cleaners. How long it will take for 4 cleaners. Now, instead of going straight from 7 to 4, I think what I'll do first is work out how long it will take for 1 cleaner. 1 cleaner. I think that would be a better way to go. So obviously, it's going to take longer if you've only got 1 cleaner compared to 7 cleaners. And we're assuming that they all work at the same rate and there's no one cleaner who's better than the other. Let's assume they're all sort of robot cleaners. Well, it's going to take 7 times as long, isn't it? It's going to take 7 times as long. So what we'll do is we'll do 3 1/3. Now there is a mixed number button on your calculator. So if you press Shift and the fraction button, it gives you a mixed number. So 3 1/3. And we're going to multiply that by 7. Because it's going to take 7 times as long. And it gives us to us as an improper fraction. I think I'll leave it like that. I prefer dealing with improper fractions anyway. So 70 over 3 hours. Okay, if you did want to convert that to a mixed number, there is also a button above the SD button. So if you press SD, that converts it to decimal. Okay, and back. But the one above the SD, so if you press Shift and SD, you can see that that does convert it to a mixed number. Let's write that in anyway. So let's just put or 23 1/3 hours. Okay, it doesn't really matter which one we choose. But now let's look at 4 cleaners. So 4 cleaners, now we're going to divide because it's going to be quicker for 4 cleaners compared to 1 cleaner. And it's going to be 4 times quicker. So let me just show you what I did. To go from this one to this one, I multiplied by 7. And now we're going to, sorry, not multiply, we're going to divide by 4. So we've got this value here and we just need to divide that by 4. And that gives us 35 over 6. And if we just convert that to a mixed number, we get 5 5/6. So that's 5 5/6 hours. So that's how long it takes for the 4 cleaners to clean the house or the hotel. Now, we're told how much they get paid. So each cleaner is paid £11.50 for each hour or part of an hour they work. How much will each cleaner be paid? So if they get paid £11.50 per hour and they each work 5 5/6 hours, to work out how much money they get, we just need to multiply. So we're going to do 11.5 multiplied by 5 5/6. So we've already got the 5 5/6. So we just need to multiply by 11.5. And that gives us this fraction here, but that doesn't really mean anything. So I think if we convert it to a decimal, that will be more meaningful. So that's going to be £67. And we're going to have to round this to 8 pence. So £67 and 8 pence. Question 12. Megan invested £17,500 in savings in a savings account for 3 years. She was paid 3.9% per annum compound interest for each of the first 2 years. And then she was paid R% interest for the 3rd year. So we don't know what that is. And then Megan had this amount of money in her savings account at the end of the 3 years. Work out the value of R. Give your answer correct to 1 decimal place. Okay, so she invested £17,500 in a savings account for 3 years. Now, for the first 2 years, she was paid this amount of interest. So we can work out how much money she's got at the end of her, how much money she's got in her account at the end of the 2 years by multiplying this by 1.039. That would be at the end of 1 year. So if we do that squared, that would be at the end of 2 years. So first of all, let's type this into our calculator. So 17,500 multiplied by 1.039 squared. And if we press equals, so that gives us £18,891. Now I'm just going to write down, even though this doesn't make sense, I'm just going to write down everything just so I don't lose any accuracy. I will round at the end, but let's just leave it like this for now. So that's how much she's got after 2 years. Now at the end of 3 years, she's got this amount in her account. So she's going to invest 18,891.6175. And the multiplier, we don't know what the multiplier is, but let's just call it X. So she's going to multiply the investment by X, and at the end of that year, she's now going to have £19,307.23. So to work out X, well, we just need to divide. So we're just going to divide this by this. So we've got £19,307.23 divided by, I'm just going to put answer because that was already saved on the calculator. Press equals, and we get 1.021999,837. Now just be really careful, this is not the amount of interest, this is just the multiplier. To work out the amount of interest, so R, okay, well, what is the value for R going to be? If our multiplier is 1.02, well, this is just going to be, we're just going to move take away 1 and move the decimal point over here. So it's going to be 2.1999837. And that is as a percent. But remember, we need to give answer to 1 decimal place. That's going to be 2.2. We don't need to write percent because you can see next to the percentage symbol is R. So we only need the value for R. Question 13. Enlarge the shaded shape by a scale factor of -2 with the centre of enlargement 0, 0. Okay, so first of all, let's find where our centre of enlargement is. Well, that's quite easy. 0, 0 is just here. We're just going to enlarge it about this point. Now, the scale factor is -2. So the way I like to do this, there's a few different ways you can do it. But first of all, if we pick a point on our shape, notice what have we done to go from our centre of enlargement to this point? Where have we moved? Well, we've moved 2 to the left. So I'm going to write this as a vector. So we've moved 2 to the left, so that would be -2. And we've moved down 2, so that would also be -2. And because we're enlarging by a scale factor of -2, well, we can just multiply that by -2 to give us our new position or our new vector. So -2 times -2 is 4. -2 times -2 is 4. So what we're going to do now, we're going to go across 4 and up 4. So from our centre of enlargement, we're going to go 1, 2, 3. I don't know why I'm counting. I can see the axis here. So across 4 and up 4. That is our new point. Now let's do another point. So let's pick this point here. So to go from our centre of enlargement to this point, we are going along 5 and down 2. So we are going -5, -2. And we're going to multiply that by -2. So our new vector is going to be 10, 4. So we're going to go along 10 and up 4. That's going to be that point. I'm just going to keep repeating this process. Let's use blue. Let's pick pick this point. So we're going to go along 3 and down 4. So that's going to be minus 3 minus 4. We're multiplying that by negative 2 again. So we get 6 and 8. Yeah, 6 and 8. So we're going to go along 6, up 8. So that is up here. And you can see that the other one's going to be over here, but I'll just do it just for completeness. So this orange point here. So we're going along 6 and down 4. So that will be minus 6 minus 4. Multiply that by negative 2. And we get 12, 8. 12, 8. So along 12, up 8. So that is there. So obviously we can't just leave it like this. We need to draw it in. So I will do that. Oh, it's come up in red. I'll leave it as red. I quite like that. There are obviously other ways to do this. So you might have used a completely different method. As long as you get the right answer, then it doesn't really matter. But this is the way I like to do it. Question 14. Write this calculation in the form of this fraction where a, b, c and d are integers. Now, whenever I see fractions being divided, I always think about the keep, flip, change rule. So instead of dividing by a fraction, that's exactly the same as multiplying by the reciprocal of this fraction. So KFC basically stands for keep, flip, change. So we keep the first fraction, so x cubed minus 4x, all of that over 3x minus 6. We change the sign from a division to a multiplication, and we flip the second fraction. So it's going to be 5 in the numerator, and the denominator will be x squared minus x. So this calculation here is exactly the same as this calculation, but it's just a lot easier working with division, with multiplication. Now I can see that we can factorize some of our expressions. We can't do anything with the 5, but we can factorize all of the other expressions. So so this one here, we can factor out an x from this expression. So if we factor out an x, we'll be left with x and then open brackets x squared minus 4. And I'm just noticing we can factorize this even further, because x squared minus 4, this is a difference of squares. And if you're a bit unsure of what a difference of squares is, or what I mean by difference of squares, let me just show you. So you can see that x squared, that's a square number, and 4 is also a square number. So what we do is we just take the square root of both numbers. So the square root of x squared is x. The square root of 4 is 2. So we're going to have x plus 2 in one bracket, and then x minus 2 in another bracket. So it does seem like a bit of magic, but this is correct. And you can check this if you want, just by expanding the brackets. So x times x is x squared. 2 times negative 2 is negative 4, but then the outside term and the inside terms will cancel, because 2 times x is 2x, and x times negative 2 is negative 2x, and those two will cancel. So these are exactly the same. So what do we have? Well, we've got x, that's this x here, and then instead of writing this, I'm going to write this. So we've got x plus 2, x minus 2. So now this is fully factorized. And then in the denominator, well, we can factor out a 3. So if we factor out a 3, we'll be left with x minus 2. And we're going to multiply that by, we can't do anything with the 5. We can factor out an x from this expression. So we'll be left with x minus 1. Now we can do a bit of simplification here. So we can cancel. So x minus 2 and x minus 2, those two terms will both cancel. And notice we can also cancel the x's. Even though they're in different fractions, we've got an x in the numerator and an x in the denominator. Those will also cancel. So what are we now left with? So we are now left with, in the top, we've got 5 times x plus 2. I've just switched the two around because I prefer having the number on this side. And in the denominator, well, we've got 3 x minus 1. So we're almost done. It looks very close, but we just need to expand the brackets. So if we expand the brackets, we're going to be left with 5x plus 10, and then 3 in brackets x minus 1. I need to expand the brackets. I was just copying it out. So 3 times x is 3x. 3 times -1 is -3. And this is our final answer. I'm just going to put an arrow to say it should go down there. But it does fit the form that we need. So A, B, C, and D are indeed all integers. Part B, express this calculation as a single fraction in its simplest form. And this is worth 3 marks. Now, the key with these sort of questions, whenever you're adding fractions, is that you can only add fractions if the denominators are the same. So we need to make the denominators the same. So I'm just going to rewrite this out again down here, just to give myself a bit of room. So 3, and then x minus 1. You'll see in a moment why I've left some space here, and I'm going to do that the same on all of these fractions. So here we've got x minus 2, and finally minus 2. I'm just going to write 2 as a fraction with just 1 underneath it, because that's the same as, this is just the same as 2. So we need to make the denominators the same. So for this fraction here, it needs to have x minus 2 in the denominator. So I'm going to write x minus 2 here. If I'm multiplying the bottom by x minus 2, I need to multiply the top by x minus 2. So notice this fraction is exactly the same as this one, because these two cancel out. I need to do the same for this fraction, so it needs to have an x minus 1 in. So I'm going to do x minus 1 on the bottom and x minus 1 on the top. And now for this fraction, well, it needs to have an x minus 1 and an x minus 2. So it needs to have x minus 1 and x minus 2. And obviously we need to do that to the top as well. X minus 1, x minus 2. So now I think the next step that I'm going to do is I'm going to expand the brackets in the numerators. So if we focus on this fraction first, well, we get 3x minus 6. And now if we focus on this fraction, well, we're going to have 2x squared minus 2x, minus 2x, and we're adding this. And now this last one here, we've got quite a bit to do on this one. So I'm just going to, instead of putting it here, I'm just going to bring it down here just to give myself a bit more room. So if we expand the first part, we're going to have 2x minus 2, and then that is being multiplied by x minus 2. And now if we expand these brackets, we're going to have 2x squared, and then the outside terms will be minus 4x, the inside terms will be minus 2x, and then the last terms will be plus 4. And we can simplify this. This becomes 2x squared minus 6x plus 4. So this bit in blue simplifies to this. But notice, we are subtracting all of this. So we're going to be subtracting this. So we're going to be subtracting 2x squared. We're going to be subtracting negative 6x. And now that becomes positive 6x. Notice all of the terms are just opposite. Because we're subtracting, everything gets switched. So we're subtracting, and then we're going to be subtracting 4. So that is all over. So now I'm going to do my fraction line. That is all over x minus 2, x minus 1. Okay, because these just combine because they're exactly the same. Okay, now I think we could do a bit more simplification. So if we first focus on the x squared terms, notice we've got a positive 2x squared here and a negative 2x squared there. So those two terms will just cancel out. Now if we focus on the x terms, well, we've got a 6x, positive 6x. We've got a positive 3x. That gives us 9x. And then if we take away 2x, we're left with 7x. So we're left with 7x. And then if we do just the numbers, we've got, or the integers, we've got negative 6 minus 4. That's negative 10, minus 10. And then in the denominator, well, I think what we can do is, well, we can't really simplify that. So I think I'm just going to leave that. So x minus 2, x minus 1. So that will be my answer. Question 15. Use the iteration formula, which we've been given, to find the values of x1, x2 and x3. And we're supposed to start with x0 being equal to 2. So we're going to type this formula into our calculator, but before we do that, we need to save our first value. So to do that, if we just type in 2 into our calculator and press equals, now 2 is stored on the calculator as our answer. So now if we type in the formula, so we're going to do the cube root, so shift cube root, and then 8 minus 3 times, now instead of writing times 2, I'm going to write times answer, because this is going to change each time. And now if I press equals, it gives me my answer. So that is my first iteration. So we've got 1.25992105. Now all I need to do is press equals. Okay, all I need to do is press equals and it gives me my next iteration. And the reason why it does that is because the answer, what it's done is this answer is put back into here. So when I press equals, now it's working out this. It looks like the same formula, but the answer's changed. So this is my x2 value. So 1.616015822, and then again, now this value here, when I press equals, that's going to go into my answer, into my sort of question, to give me a new answer, if that makes sense. So I press it again and I get my new iteration. So 1.466200.026. So part B says the values of x1, x2 and x3 found in part A are estimates of the solution of an equation of the form, or this form here, where A and B are integers. Find the value of A and the value of B. So this formula that we used up here was to calculate estimates of the solution, but to find the exact solution, we need to rearrange this formula to put it in this equation here. Okay, so we don't need to worry about these small subscripts anymore. So we've got, at the moment, we've got x is equal to the cube root of 8 minus 3x. And now we need it to look like this. So the first thing I'm going to do is cube both sides. So if I cube the left, I get x cubed. And if I cube the right, well, I'm just left with 8 minus 3x. And now we want all of the x's on one side. So if I add 3x to both sides, I've got x cubed plus 3x equals 8. And again, I just want 0 on the right hand side. So if I subtract 8 from both sides, I'll be left with x cubed plus 3x minus 8 equals 0. And notice now how it's in exactly the same form as this, so we can identify our values for A and B. So A is the coefficient on the x term, which is positive 3, and B is the constant term, which is negative 8. So my values for A and B are 3 and negative 8. Question 16. Here is a speed time graph for a car. Work out an estimate for the distance the car travelled in the first 30 seconds. Now, whenever you're asked to calculate the distance on a speed time graph, you're always looking at the area under the curve. But you're not looking at the whole area, because that goes from 0 to 150 seconds. You're only going to be looking at the first 30 seconds. So 30 seconds is here. So if I just draw a line to go up to my curve. So we're only focusing on this area here. So that's what we need to calculate, this area. Now, to calculate the exact area will require a bit more mathematical knowledge than you'll probably know at this stage, because it will be past your GCSEs. But we only need to calculate an estimate. And you can see that this is almost exactly the same as a triangle. So if we calculate the area of this triangle, that will be a good enough estimate. So let's calculate the area of a triangle. So area of a triangle. Well, to do that, it's going to be a half times the base times the height. That is our formula. So it's going to be a half times 30 times the height. So we just need to work out what the height is. Now I can see that it crosses at this point here. So we're looking at this point. So what value is this? Well, we're going from 8 to 10. That's the difference of two sort of meters per second. And you can see that there are 5 squares. So to work out what each square is, we can just do 2 divided by 5. And that gives us 0.4. So each small square is worth 0.4. So this is 8, 8.4, 8.8, 9.2. So that point is 9.2. So we're going to times that by 9.2. And now let's type all of that into the calculator. 0.5 times 30 times 9.2. And we get 138. 138. And that will be in meters. So just to show you why it's meters, why it's a distance, we can just think about the units. So we're multiplying meters per second. We're multiplying meters per second by seconds. And you can see that the seconds will just cancel out and all we're left with is meters. So that is our answer, 138. So now let's look at part B. And part B is a bit trickier because we're calculating acceleration. And to do that, to calculate acceleration on a speed time graph, we will need to draw a tangent line in where at the point we're calculating the acceleration. So let me just get my highlighter out. We are calculating an estimate for the acceleration at 45 seconds. So what we do is we look at where 45 seconds is. I can see that's exactly halfway between 30 and 60. We go up to our graph and that is that point there. And what we need to do is draw a tangent line at that point. So let's draw a tangent line. It's going to be a lot harder for me doing it on here than it will be for you on a piece of paper because you can obviously get your ruler out and measure it a bit more accurately. So please forgive my line if I don't get this perfect. So let's just draw my tangent in. So this is just kind of a first go at it. I think I need to change that slightly. I think I need to make it a bit steeper. And remember, the tangent line should only just touch the graph at exactly 1 point. So just looking at it like that, I think that's probably about okay. I think not perfect, but we'll go with that for now. We'll go with that. So once we've got our tangent line, we need to calculate the gradient of our tangent line. And to calculate gradient, we do change in y over change in x. So the gradient, write it down here. The gradient is going to be the change in y over the change in x. So what is the change in y? Well, we're going from, we need to pick 2 points on our graph. And I always recommend picking 2 parts that are as far apart as possible. So let's pick this point here. And let's pick this point here. So our y value is 16. Take away this y value. Well, it's just one unit or one square less than 6. And we know that each of these is 0.4. That's going to be 5.6. So 5.6. And then our change in x, well, this point here is this point. We need to work out what this point is. So there are 10 squares between 60 and 90. That means each square is worth 3 seconds. So we've got 60, 63, 66, 69, 72. Yep, that's 72. So it's going to be 72 minus, well, this is just 0. We're on time equals 0 there. So I'm just going to type all of this into the calculator. So we've got 16 minus 5.6, and then all of that is over 72. And yours will be different to this. Okay, everyone will have slightly different results, but the final answers should all be very similar. So I get 0.14 recurring for me, 0.14 recurring. And for my answer, I'm just going to round that to 3 decimal places. So 0.144. Now, just to, again, reinforce that this here is only an estimate. So all sort of students' answers will be different, but there will be margin for error. So hopefully I'm within that. I'm not sure if I am, but it should be around this value here. Question 17. Here are the first 5 terms of a sequence. Find an expression in terms of n for the nth term of the sequence. So the first thing I'm going to do is just copy out the sequence again. So we've got -4, -1, 6, 17 and 32. And now I'm just going to look for the first difference between terms. So what are we going up by each time? Well, here we are adding on 3. Here we are adding on 7. And then we're adding 11. And finally, we are adding on 15. So the first difference is different. So we're going to have to look for the second difference. So here we are adding on 4. And then it's going to be +4 again and +4. So the second difference is the same. Therefore, we are dealing with a quadratic sequence. And a quadratic sequence always has n squared in. So we just need to work out what the coefficient on the n squared term is now. And to do that, well, we look at the second difference and we just take half of that. So half of 4 is 2. So we know our sequence is going to start with 2n squared. And I can even write that in my answer line. because I know it's going to start with 2n squared. So let's first of all, well, now we've got our quadratic part, we need to write down what the 2n squared sequence is. So let's write that down here. So we've got our 2n squared sequence. So the first term in our sequence will be 1 squared, which is 1 times 2. That's 2. Our second term, 2 squared is 4. 4 times 2 is 8. 3 squared is 9. 9 times 2 is 18. 4 squared is 16. 16 times 2 is 32. And 5 squared is 25. 25 times 2 is 50. So this is our 2n squared sequence. And now what we need to do is we need to take this sequence away from our original sequence to see what's left over. So I'm just going to copy down our original sequence just above this sequence that I've written out. So we've got -4, -1, 6, 17 and 32. And what we're going to do is we're going to subtract. So let's just put a line in here just to show what we're doing. So -4 minus 2, well that's -6. -1 minus 8, that is -9. 6 minus 18 is -12. 17 minus 32 is -15. And 32 minus 50 is -18. Now we've got a new sequence here, but this sequence is a linear sequence because it goes up by the same amount each time, or it goes down by the same amount each time, I should say. So what is the difference between terms? I can already see that it's a linear sequence, but you can see that we're going down by 3 each time. So for each term, we are subtracting 3. So what is the nth term of this sequence? Well, because we're going down by 3 each time, we know it's going to start with -3n. So it's going to be -3n, and then to get to this sequence here, what else do we have to do? Well, we have to take away another 3. Notice that -3 times 1 is -3. We have to take away another 3 to get to -6. -3 times 2 is -6. We have to take away another 3 to get to -9. So this is our nth term for this sequence here. So we've got our quadratic part, we've got our linear part. Now for our final answer for our nth term of our original sequence, we just combine the two together. So it's going to be 2n squared minus 3n minus 3. And this is our final answer. If you wanted to check your answer, once you've got it, you could substitute values for 1, 2, 3, 4 and 5 in here, and it should pop out the sequence that you've been given. Question 18. ABC and ADC are triangles. The area of triangle ADC is 58 meters squared, which is, you see this bottom triangle here. Work out the length of AB. Give your answer correct to 1 decimal place. So we've got quite a lot of information here, and I've just noticed it's worth 5 marks, so it's going to take quite a long time to get our answer, but we just do it in stages. So what do we know? The area of ADC is 58 meters squared. So that is this area here. ADC, 58 meters squared. And what are we trying to find out? We're trying to find out the length of AB. That's this length here. Okay. Right. Now, whenever you're given a triangle with an area in, if it's not a right angle triangle, you should be thinking about the sine rule. So let me write down what the sine rule is. So it states that the area of a triangle, and that's any triangle, can be calculated by doing a half AB times the sine of C. Now hopefully you know what these letters correspond to, but the angle, this is angle C. Okay, this is what we're going to use for angle C. And A and B, well, those are just the side lengths either side of the angle. So let's call this one A and let's call this one B. Now, we've got all of the information apart from B. Notice we've got the area, we've got the angle, we've got A, we just need to calculate B. So let's put all of this data into our formula. So the area, well, that's going to be 58. That's going to equal a half times A. A half of 12 is 6. So 6 times B times the sine of C. Well, C is 102 degrees. So 102. Okay, now we want to get B on its own. So first of all, if we get rid of this sine of 102, we can divide both sides by this. So we're going to be left with 58 divided by the sine of 102. That is going to equal 6b. And then finally, to get rid of this 6, we can just divide everything by 6. So we're going to have 58 over 6 times the sine of 102. And that is going to equal b. Okay, so let's just put this into the calculator now. So if we get the fraction button up, 58 divided by 6 times the sine of 102 degrees. Press equals. So we get 9.88. I'm just going to put dash 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 because I'm actually no. I'll write the whole thing down. So we've got 262,575. Okay, so that is B. That's this here. And now we've calculated this side length, we can calculate this length here. And this is going to be really useful because it's part of this triangle, so it should help us calculate AB. So now, are we going to use the sine rule or the cosine rule to calculate this? Well, we're going to use the cosine rule because we've got the angle and we've got the side length either side. So what is the cosine rule? Let's write it out down here. So let's do it in a different colour actually because green doesn't show up very well. So let's do it in purple. So the cosine rule is a squared is equal to b squared plus c squared minus 2bc times the cosine of a. But just be careful because we did have these labels on here, but these labels are going to change now. So now our angle is a. So I'm going to make that clear that our angle is a. So these two side lengths are b and c. So let me just cross these off and put b and c. Okay, so let's work out what this is. So b, that's 12, so it's going to be 12 squared. C is, well, we know what c is now because we've just calculated it. So remember, this is c, not b. So try not to get confused with my lettering. So we've got all of this business. So I'm just going to call this answer because it's stored in the calculator. I can actually use this going forward. So I'm just going to call that answer squared. Minus 2 times b, so 2 times 12 times c, which was our answer, times the cosine of a, which is 102 degrees. So I'm going to put all of this information into the calculator, and you can see that I don't need to type in all of this. I can just type in answer because it's already saved on my calculator. So remember, this is a squared. So let's type this into the calculator. We've got 12 squared plus answer squared minus 2 times 12 times answer times the cosine of 102 degrees, and we get 290.979414. And no, that's not the length of this because remember, this is a squared. We need to square root it. So we need to square root. I'm just going to put an arrow just to show that we're square rooting the previous answer. So what does that actually, let's do it down here just to give ourselves a bit more space later on. So we just need to square root our answer and we get 17, that looks a bit more like it, 17.05811.871. So that is this length here. Okay, we're getting on to the home straight now because we've just got one more thing to do. And for this, we're going to use the sine rule. So if we just think about what information we've now got. So we've now got this here. So I'm just going to write 17. I know it's not exactly 17, but I'm just to show you that we've got this length. So we've got the angle and the side length opposite it. And we've got this angle and we need to calculate the side length opposite it. If that makes sense. That probably didn't make sense, but we're going to use the sine rule because we've got pairs. So let's write down what the sine rule is. So the sine rule states that a over sine a, and I will need to change my letters again, is equal to b over sine b. So now let's think about what a and b are. So if we call this a, this is angle a, and if we call this b, well, this is angle B. Oh, and that's quite nice because that is still B, so that hasn't changed. So what do we have? Well, the only thing we need to calculate is A. So we've got A over sine A, so that's sine of 51. Sine of 51. That is equal to B, which is 17, over sine of B, which is 112. So to work out what A is, we just need to rearrange the formula. So if we multiply everything by sine of 51, we're going to have A is equal to 17 times the sine of 51. All of that over the sine of 112. And hopefully when we put this into the calculator, it should give us our answer. And I'm not going to use 17. You can see that we've got that stored on our calculator, so we can just use answer for that. So we're going to get the fraction button up, and we're going to do answer times the sine of 51, sine 51, and then go into the denominator and do the sine of 112, 112. Okay, and then press equals. I think we probably should have had a drum roll for that because we deserved it. And we get an answer of 14. What do we need to round to? 1 decimal place. So that would be 14.3. 14.3. You don't need to give units because that's provided. And that is my answer. Question 19. A, B and C are 3 spheres. The surface area of sphere A is 25 centimeters cubed. And the surface area of sphere B is 36 centimeters cubed. The ratio of the radius of sphere B to the radius of sphere C is 2 to 3. Work out the ratio of the volume of sphere A to the volume of sphere C. This is worth 3 marks, this question. So first of all, if we take a look at this information here, because we've been given the surface area of sphere A and B, so we can work out the ratio. So if we write down A to B, so A to B, and this is to do with the area, the surface area. So it's going to be 25 to 36. Now, with this information, we can work out the ratio of the lengths, or the in this case the radius. So the length scale factor, the area scale factor is 25 to 36. To work out the length scale factor, well, we just square root both of these values. So again, this is still A to B. So the square root of 25 is 5, and the square root of 36 is 6. So now we've got this length scale factor of A to B. And now if we look at this line here, we're told what the length scale factor is of B to C. So B to C, because we've been given a length. The radius is a type of length. So the ratio of B to C is 2 to 3. And now, because I've got these pairs of ratios, I can use that to calculate the ratio of A to C. Because notice they both have a B in common. So if we can get the B's the same, we can just look at the values for A and C. So at the moment B is 2, I can turn that into 6 by just multiplying by 3. So if I multiply both numbers by 3, the ratio is not going to change. So 2 times 3 is 6, and 3 times 3 is 9. Notice the ratio 2 to 3 is exactly the same as the ratio 6 to 9. So now the B's are the same, we can work out the ratio of A to C. So A to C, well, A is going to be 5 and C is going to be 9. So 5 to 9 is the ratio of A to C. But again, this is the length ratios. In the question, it says work out the ratio of the volumes of A to C. So let's do that. So the volume of A to C. So because we've got the lengths, all we do to calculate the volume is we need to cube each of these numbers. So it's going to be 5 cubed to 9 cubed. And I'll just use my calculator for that. So 5 cubed, that gives me 125. And then 9 cubed, that gives me 729. So that is my answer, 125 to 729. Question 20. The histogram gives information about the heights in meters of the trees in a park. the histogram is incomplete, which we can see here. 12% of the trees in the park have a height between 2.5 metres and 5 metres, and none of the trees in the park have a height greater than 25 metres. Complete the histogram. So first of all, let's just go through what this histogram is showing us. So you can see we've got height along the x-axis and frequency density along the y-axis. And these rectangles, inside these rectangles, the area of these rectangles is going to represent the frequency. So we can see this statement here, it says 12% of the trees in the park have a height between 2.5 metres and 5 metres. So that is this category here. So whatever we find for the frequency in this box, well, that represents 12% of the total. So we just need to bear that in mind. So let's go through each of these rectangles and calculate the area. So this first one here, let's call that A. Let's do it up here. So the width of this rectangle, well, that's 2.5 because it's half of 5. So it's going to be 2.5. And then the height, that looks like it's 1.6. We're going to do 2.5 times 1.6. 2.5 times 1.6. We should get a whole number because we're dealing with the number of trees. And we get 4, which is nice. So there are 4 trees that measure between 0 and 2.5 metres. Now let's have a look at this column. So B, again, it's going to be 2.5 wide. And the height is 2.4. 2.4. So 2.5 times 2.4 times 2.4. And we get 6. So there are 6 trees in this category. Now let's do this one. So it's going to be 5. Well, let's just label it first. C. It's going to be 5 wide and the height is 3.2. 3.2. I think I can do that in my head. I think that's 16, but let me just double check. So 5 times 3.2. Yay, it is 16. So give myself a pat on the back for that. 16 trees. And then finally, D, this category. Well, it's going to be 10 wide. That should be nice and easy to calculate. And 1.1 high. And yep, that is going to give us 11 trees. So we've calculated, I forgot to write in these values. So 16 and 11. Okay, so we know that there are 6 trees in this category, and that represents 12% of the total. So we can work out how many trees there are in total from this. So we can say that 6 out of the total, I'm just going to write X because we don't know that. Well, that is equal to 12%, which is 12 out of 100. So now we can work out what X is because, 6 is half of 12, so X is going to be half of 100, so X is going to be 50. So that means there are 50 trees. So because there's 50 trees, we can work out this missing one because that's all that's left. There's no other trees. It said that there were no trees greater than 25 metres, so all the ones that are missing must be in this category. So if we just sum all of these together, so 4 plus 6 is 10, that's 26, that's 37. So there must be 13 in this sort of category here. So now we've worked out there's 13, we can work out how tall the bar is going to be because we know that this is 5. So it's going to be 5 times something is going to give us 13. So to work out the height, we're just going to do 13 divided by 5. So 13 divided by 5. And that gives us 2.6. So let me get my line tool out. So this is 2. This is 2.5. This is 2.6. So we're going to go along to there. And then we're going to come down to here. And we're done. That's all we need to do. We don't need to colour it in or anything like that. Let me just write down here. I've just noticed that I haven't put 2.6. So just in case there's some confusion about where this line is, you can clearly see that the height is 2.6. Question 21. There are 15 counters in a bag. There is an equal number of red counters, blue counters, and yellow counters in the bag. There are no other counters in the bag. 3 counters are taken at random from the bag. Work out the probability of taking 1 counter of each colour. So we need to pull out one of each colour. Well, let's write down all of the different combinations of getting one of each colour. So we could get red, blue, yellow. We could get red, yellow, blue. And then we could get blue, red, yellow. We could get blue, yellow, red. This is a bit like saying the blue lorry, yellow lorry situation, which I struggle with. And then we could have yellow, blue, red, and yellow, red, blue. So yes, there are 6 different combinations that we can have. So now let's work out the probabilities. So there are 15 counters in the bag, and there are an equal number of red, blue, and yellow counters. So there must be 5 red, 5 blue, and 5 yellow, just based on this information here. So to pull out a red one, let's say we're starting brand new, pulling out a red counter. Well, there's 5 red and there's 15 in total. So it'd be 5 out of 15. Then let's say we pull out a blue counter. And remember, when we're calculating probabilities, we are multiplying. So the probability of getting a blue counter, well, there are 5 blue counters, but now there are not 15 counters overall because we've already taken out a red one. There are now only 14 counters. And then to pull out a yellow one, well, there's still 5 yellows because we haven't taken out any yellows yet. So there's still 5 yellows, but now there are only 13 counters. Now, to do all of these 6 different combinations, these are going to be exactly the same probabilities because it doesn't matter which way round we do it, the probabilities are still going to be the same. So first of all, let's just work out what this probability is, and then we can just multiply it by 6. So we've got 5 out of 15 multiplied by 5 out of 14 multiplied by 5 out of 13. And we get 25 out of 546. Let's just write that. Let's just bring that down here now, because we're going to multiply that by 6, because that's only one possible way of getting it. There are 6 other ways that we could get it, and they'll all be exactly the same in terms of the probability. So we just need to multiply that by 6. So times by 6, and we get 25 out of 91, and that should be our final answer. Question 22. Solve algebraically the simultaneous equations. So it looks like we've got one quadratic equation and one linear equation. So whenever you've been given one of each, you should be substituting the linear equation into the quadratic equation. So the first thing I'm going to do is rearrange this linear equation. So you can either make x the subject or y the subject. It doesn't matter which one you do, you'll still get the same answer. But I think I'm going to make y the subject. Let me just write it up here. We've got 5x plus 2y is equal to 6. So to get y on its own, first of all, I'm going to subtract 5x from both sides. So I'll be left with 2y is equal to 6 minus 5x. And now I can divide both sides by 2. I get y is equal to 6 minus 5x, all of that over 2. So now we've got y on its own, we can substitute that into our quadratic equation. So I'm going to do that over here now. So what we've got 2x squared plus y squared. Now instead of writing y, I'm going to write this fraction. So if I put it in brackets, 6 minus 5x over 2, and all of that is being squared, and that equals 12. So now let's square this fraction. So we've got 2x squared plus, and what I'm going to do is I'm going to do it step by step. So I'm going to write out double brackets. So I'm just going to write it out like this. So 6 minus 5x times 6 minus 5x, like that. And then that all of that is over. It's not over 2, because when we're squaring a fraction, we square the numerator and the denominator. So 2 squared, all that is 4. And then that equals 12. So now let's do another line. So we've still got 2x squared plus, now let's expand the brackets. So we've got 6 times 6, so that's 36. We've got 6 times negative 5x, well that's negative 30. And then we're doing that again here. So that's two lots of negative 30. That's negative 60x. And then negative 5x times negative 5x, that will be positive 25x squared. And then all of that, we need to remember all of that is over 4. And that equals 12. So now what can we do? Well, we can get rid of the 4. So let's get everything on one line. So to get rid of this 4, we can just multiply everything by 4. So 2x squared times 4, that will give us 8x squared. And then if we multiply this fraction by 4, that will just get rid of the 4. So we've got 36 minus 60x plus 25x squared. And that equals 12 times 4 is 48. So now we've got everything on one line. It's going to make it a lot easier. So if we get all of the x squared terms together, 25x squared plus 8x squared, that will be 33x squared. And then we've just got minus 60x. And now if we get rid of this 48, put it on the left hand side, so we'd be left with 0, we need to subtract 48 from both sides. So 36 minus 48, that will be negative 12, and that equals 0. Now I don't think I can simplify this anymore, but it is in a nice format that we can solve. So we can solve this quadratic equation using the quadratic formula. So hopefully you know the formula off by heart. But if you don't, it will be given to you in your exam. So it is at the front of the exam paper. So to solve this quadratic equation, the solutions to this are x equals plus or minus, not plus or minus, it's negative b. It starts off with negative b. Now b is negative 60. So if it's negative of negative 60, that's just going to be positive 60. And then plus or minus the square root, and I'm just going to make this quite long so I can fit everything underneath it. And that's b squared, so negative 60 squared, I can do that in my head, that's just 3,600, minus 4 times a times c. So a is 33, and c, we can see, is negative 12. And then the whole thing is over 2a. So 2 lots of 33, well, that's just 66. So we've got our formula here. We don't need to do this in our head or on paper. We can just pop that into the calculator. And we are going to have two solutions because we've got plus and minus. So I'm going to do the positive solution first. So we get the fraction up. So we've got 60 plus the square root of 3,600 minus 4 times 33 times negative 12. Close brackets, and then in our denominator we need to put 66. And let's press equals, and it's really nice to see the fact that we've got an integer answer. So all of this complicated calculations, we're left with just an answer of 2. You should be quite confident that that is the right answer. So that's one of our solutions. Remember, we need the negative solution as well. So we don't need to type in the whole formula again. We can just go back to where we had the plus, just delete that and put in minus, press equals, and we've got our other solution. So x is equal to negative 2 over 11. Now, we don't just stop there. A lot of people will be tempted just to put that in their answer line, but we've forgotten y, or we haven't forgotten it. We haven't worked out y yet, so we still need to calculate what y is, and we can do that by substituting these values for x into our equation that we've got over here. So there was doing this, not only was this useful for substituting into our quadratic equation, but now you can see that we can calculate y just by substituting these values into where we've got an x. So let's deal first of all with this, the positive solution for x. So we're going to have y is equal to 6 minus 5 times x, and instead of x I'm going to write 2, and then all of that is over 2. So I'll pop that into my calculator, and then the other solution will be y is equal to 6 minus 5 times this x, so negative 2 over 11, and then all of that again is going to be over 2. So let's put this into the calculator. So we've got 6 minus 5 times 2. I'm just going to put it in brackets so I can just replace this 2 with the other one when I've finished with this one. And then all of that is over 2. And we get negative 2, so that is my value for y, my first value for y. My second value for y, all I need to do is go back into the formula, change the 2 to a negative 2/11. So negative 2/11, and then press equals, and that will give me my other solution. So that will be 38/11. So now we've got both of our solutions. We can put them in the answer line, but just make sure you pair them up correctly. So our first solution, we've got x is equal to 2 and y is equal to negative 2. So that is one solution. I'm just going to box it to make it clear that that's one solution. And my other solution is going to be x is equal to negative 2/11 and y is equal to 38/11. So that is my second and slightly more complicated solution. Question 23, and you can see from the bottom here that you'll be pleased to know this is the last question on the paper. So we've got this formula here, and we're told that C is 11.2 correct to 3 significant figures. By considering bounds, work out the value of D to a suitable degree of accuracy. Give a reason for your answer. Okay, so we've been told that C is 11.2 correct to 3 significant figures. So let's work out the lower bound and the upper bound of C. Well, if it's been rounded to 3 significant figures, the lower bound is going to be 11.15, because if we round this to 3 significant figures, the 5 will tell us to round this up to 11.2, so that will be the minimum value. And then the upper bound, well, it's just going to be the same, but in the opposite direction, so it's going to be 11.25. So now we've got the upper and lower bounds, let's calculate D. So D is going to be 1/5 multiplied by, let's do the lower bound first, so 11.15 cubed, and we'll obviously need a calculator for this. So 1/5 times 11.15 cubed. And we're going to write down everything on our calculator display. So 277.239175. Let's do the same for the upper bound. Let's just actually write down here lower bound. So D is going to be 1/5. So everything's going to be the same. I'm just going to change this value. 11.25 cubed. Actually, I think I can just go into my calculation and just change this to a 2. I think that's everything else is exactly the same. So if I press equals, so this will give me 280. No, that doesn't sound right, does it? 11.25 cubed. Oh, I guess it is. 284.765.625. So that is my upper bound. So now we've got our lower and upper bounds for D. We know that the exact answer will be somewhere in between, but we don't know what the exact answer is. So we're just going to have to give a value to a suitable degree of accuracy. So let's think about the sort of the worst estimation of our answer. So what would we know that they both round to? So we know that they both round to 300. So if we're thinking about one significant figure, we can see that they both do round to one significant figure. You can see that this rounds to 300 and this also rounds to 300. Now let's think about two significant figures. So let's try and be a bit more accurate with our answer. Do they both round to the same number if we round to two significant figures? Well, this one, if we round this to two significant figures, that would round up to 280. And this one, well, this would round down to 280. But notice they both round to the same number. Okay, now let's think about three significant figures. So if we round this to three significant figures, well, this would be rounded down to 277, and this one would be rounded up to 285, but they're completely different, so we can't round to three significant figures. So this one here is the one we're going to have to use. So we can say that D is equal to 280, but we need to give a reason for our answer, and we can say that both the lower bound and upper bound round to 280, and then I'm just going to put using two significant figures. Okay, they do both round to 300, but 280 is a much better number to use because it's more accurate. Okay, so our answer is going to be 280. So the key with these sort of questions is to try and find a number where both the upper and lower bound, they round to the same number. And you can see that 280 works because they both round to 280. Okay, so we've come to the end of this paper, and hopefully that was useful in your revision. And just to let you know, I will be doing paper 3. So after your exams, hopefully they go well. But after those exams, if you do want to come back to the channel and give paper 3 a go, I'll be more than happy to welcome you. So thank you very much and take care. Bye-bye.